Hey, welcome back to Better Through Tech. Today, we're going to be looking at a couple different types of motion detectors and how to set them up. Our first build, we're going to be setting up a flashing light with a buzzer to help keep our younger viewers interested on how to do this. Maybe if you want to keep your siblings out of your room, and you have no way of keeping track of whether or not they're going in there, this would be a good way to do it. You set this up by your bedroom door, and the alarm will go off, notifying you that maybe they're where they shouldn't be. Or, if you're my wife, from how she puts it, if you have a man cave, you can keep your wife out of there. Not to say that women, if you were programming this, if you have, what would you call it? A she cave, I think it is. You could do, or she shed. There we go. It's a she shed. Yes. So you could do exactly the same thing, and you could set this up and keep your husband out of there. But after we're done doing that, we'll take a step back and we will actually program this right here. We will program a motion activated yard light. Ours will be obviously very much more simplified, but it'll work exactly the same way. And if you want, you can put a transistor in there, or a is it relay? Yeah, put a relay in there, and you can power much bigger light sources. So if you really wanted to use your own system to light up an area, you most definitely could. So the sensors that we're going to be using, ones we're going to take a look at anyways, is going to be one of these. I will have one of these we'll program out. This is a Doppler radar. These are very impressive little chips. Very impressive. I'm super impressed with using these things. You have to be careful where you set these ones up, though. They will or can work through certain materials. So if you set these up too close to a wall, they could react to something outside. When I plug mine in, I will show you. I can actually trigger mine through my desk. I can put my hand underneath the desk and it will trigger it, and I'll show you that here at the end. But these are very incredible little chips. So cool to use. The one that we're going to get started with, though, is this PIR sensor. It uses infrared to detect movement and then will trigger our system to turn on. Both of these use exactly the same pinout. I do believe that the Doppler one, you can hook up to 3.3 volts. But the way that we're going to be using it will be 5 volts, which is perfect for using on an Arduino Uno, and maybe a couple of the other logic boards that have logic level. Well, 3.3 and 5 volts is both logic level. But for our purposes, it will be 5 volts. But they both have the exact same setup. You have a ground, a high, and you have the output. And the output's what we're going to use to connect to the Arduino. So with that being said, let's get over to Tinkercad real quick, and we'll show you the layout that we have going on here. Now what we got is we have our sensor here, our PIR sensor. It's set up just like this. You have your ground, you have your power, which is positive, which in our case is 5 volts, and then you have your signal or out, which we are going to send, at least on my build anyways. You can put it on whatever pin you want. I'm going to put mine on 4. I have the buzzer, which will put the ground and connect it directly to pin 13. Again, you can make it whatever pin you'd like. It doesn't have to be exactly what mine is. Just if you change it, make sure to change it when you write the code, or else it's not going to work. And then again, just like we did in one of our previous episodes, we're going to set up our LED to get it to flash, and then I'll switch it out to a white one to better fit the scenario, and we will use it as a yard light. Now you will see on my board I have the PIR sensor, I have the buzzer, and then I have what is called a Piranha style LED. These are very high powered little LEDs. If you want to get them, by all means, they're plentiful on places like Amazon, Adafruit, SparkFun. I think it's SparkFun. Let me get back to you on that one. But you can find them easily at those places. Just beware that they're very bright. Don't look at them. They can hurt your eyes. So please be aware of that. Anywho, let's go ahead and open up our IDE and let's get started, shall we? So again, as always, let's go ahead and create some space up here at the top because we have a few global variables that we need to set up. And we are, again, as always, we're going to start off with our LED. And just per the Tinkercad setup, we got our LED on pin 2. We have our buzzer on pin 4. And then we have what I'm going to call motion. And we're going to have that, did I say pin buzzer? You know what, that is on pin 13. And then we'll put that on 4. And then we have some containers or some holders that have to hold some values for us. Now, I just cannot enunciate right now. Holy cow. I apologize, everybody. We'll get our status in there. Then we'll put a state in there. And then we are going to use a bool or a boolean. And we're just going to call this on. You can call it whatever you like. You don't have to use the same values that I'm using. You can use other ones. Just make sure to keep it consistent across your programming. That's the only thing I have to say. If you got to change it, make sure to stick with it. Because if you misspell it even by a little bit or accidentally change the name, you're going to have a fun time chasing that down. Or in the words of, South Park, you're going to have a bad time. So next, we're going to go increment, because we need this to have it be a counter. We're going to start that off on 0. And then once we get that done, so those are our holders. Now we have to do our timers. So we're going to do an unsigned long. And this one's going to be prev, and we're going to call this time. So that way we can separate one from the other. So that one's prev time, and then we're going to use an int. Call it wait. And that one... so I did some testing with this code before I decided to start recording this. For some odd reason, 60,000 does not want to work on this. I don't know why. And yes, I know the comma doesn't belong there. I'm just doing this to make a point. When I ran this code earlier, for some odd reason, I couldn't get 60,000 to work. 60,000 in milliseconds is 1 minute. It does not work. So we are going to do 30,000 because that's a half of a minute, and it does work. And I will show you how to get around that so that way you can do multiple minutes worth of time on these lights. So we'll set up at 30,000 milliseconds because that is a half a minute. And then we'll go down again. We're going to set up another unsigned long. Whoop. Holy cow. Okay, unsigned long. We're going to do another prev, but this time it's going to be called blink, so we can get the two separated. And this one we're just going to call hold. And this can be whatever you want. This is just going to control the speed of how fast the buzzer and the LED light are going to blink. Next, now that we're done with that, we're going to come down into our setup, and we have to tell the Arduino what the pins are, of course, as always, right? Our LED is output. Our buzzer is also an output, all uppercase if you don't remember. And then our last one, we're going to pin mode that one as well, but the motion, that is going to be an input because it's going to send information into the Arduino so it knows what to do with it. And let's go ahead and set up a serial. Serial begin at 9600. We'll keep the baud rate there. It's always a good one to go to. Now that we're done with that, let's go ahead and get into the fun stuff. Let's see. Where do I want to start at? Let's go ahead. Yeah, we'll start right here at the loop. So what we're going to do is we have to send the motion into something, right? So we're going to say digital read motion. So what this is going to say is it's going to read motion and put it in this container, into in this status. Or status, however you want to say it. That needs to be up a little bit. Can't have it at the end of that bracket. It will not work. Not for the way we have it set up right now. And then, what we're going to do is we're going to put that in a comparative operator. We're going to compare it. So we're going to call status. If it is equal to high, remember, 2 equal signs is equal to, so we're comparing. the values here is equal to high. Then this is where our Boolean is going to come into place. On is going to equal true. And then increment is going to equal 0. And I'll show you why. Once we're done programming this out, I'll show you why I'm doing this the way that I'm doing it. I know this is probably not going to make a lot of sense right off the bat, but trust me, there's a reason why we're heading this direction. So next, we're going to space this out just a little bit, and we're going to give it our next command. We're going to say if status is equal to low, and this can be an if else. I just did this to make it a little more readable, but we could have set this as an if else, but I did this to make the situation a little readable. I want to make this so that way people can, it's easier for people to read and understand. But anywho, this is where our first timer is going to go. So our mils minus prev, you remember, prev time. So this is going to be our initial timer, because this is what's going to hold once the motion sensor has tripped or activated. We need something to hold it on. And this is what's going to do it. So our prev time, and it's going to be more than or equal to our wait. Remember that 30,000, so that's a half of a minute. And open curly bracket, and then we're going to say increment, right? Plus plus, we're going to use that shorthand again. And then we got to use that updater. Prev time is mils. So there is our updater to make sure that our mils counter can stay on track. Once we're done with that, we'll come down here, we'll space one more time, and then we have to tell it what to do when the timer is up. When the timer is done, we have to tell it what to do. So that's going to be this right here. If increment is more than or equal to, and we're going to say 2, because this is what this is going to do, is it's going to count out that 30,000 from up here. It's going to count that out, right? But we're going to tell it that it has to count it out twice. That will equal our 60,000, and that's what's going to give us that minute. And we're going to go increment equals 1. You don't have to have that. Let's say 2. That's supposed to be 2. You don't have to have that in there. I like to have it in there so that way it doesn't keep on counting, because mils, the mils is a core timer. It never stops. So if you don't tell it when or where to stop, it will just keep on going and going and going. And so if you don't add a limiter to your command, it will keep on counting with it. So I lock it in so that way once it hits 1, 5, 10, whatever, it will stop wherever this is telling it to stop. But once it hits there, once increment is more than or equal to 2, increment equals 2. Remember, 1 equal sign is an assignment operator, so we're assigning that value to it. Then we're going to say that on is that Boolean. We're going to say it is false. And let's see where we at. Space that out. You know what? I probably should do this right now so that way I don't lose track of it. That's the end of the loop. And let's see, that's end of those commands there. And then, so what is that going to tell it? Now what we do is we're going to give it its final command for the loop, and we're going to say if. And this is we're going to use a Boolean operator. I'm going to say on is equal to true. Then we're going to say light is equal to high. Else light is low. And that's how we're going to set up our comparative operators here, and how we're going to tell the system to turn on or turn off. Now we're going to come down here and go void light, because this is going to be our function that's going to control everything. And we're going to say int val. You can give that name, you can name it whatever you want. We're going to name it, for my demo here, we're going to call it val, because that's the value where we're bringing in. I'm going to come down, and then we're going to write this. If val is equal to high, then we're going to say what? We're going to have that. We're going to use that blink mils that previous prev blink, right? So we're going to use that other mil here, and this is what we're going to use to control the blinking of the LED lights. So the cool thing is we're designing it like this, so everything is non-blocking. So both the sensor, the buzzer, and the LED can operate all at the same time on different timers and not jam up the system. So we're going to go here, space out that, and we're going to minus, and we're going to go prev and blink, right? Is more than or equal to, hold, get that P out of there. And if you remember from our last videos, we're going to use that little clever switchback. So we're going to say state is equal to 1 minus state. And that will switch back and forth between on and off. It'll turn it on, then it'll turn it off, back and forth, right? And we need to have our updater in here again. We'll go blink and mils to update the system. Then we will come, okay, yeah. So we put our else in here because we have an if. Now we're going to use our else. Else, we're going to say that if this is high, it'll count this out. Else, this is going to read low. So we need to tell it what to do when it shuts off. So digital write, LED, and we're going to say low, because we need to turn the system off when it's not going, right? Then we're going to say digital write, buzzer is low. And then one last piece, because depending on how our timing works, this may not always read off when it hits the limit. It could read on when this hits the limit and shuts off. So your state will still be on. So we need to make sure that every time that it shuts off, state reads off as well. So that way you don't get stuck with an on signal when this times out. So we're going to say state is equal to 0. So what that says, literally, so once this maxes out, turn off the LED, turn off the buzzer, and make sure state is equal to 0. So that way it doesn't try to keep on going. So a little bit of preventive maintenance there, just to make sure we don't have any errors or it tries to go off and go do its own thing. But if it is running, we have to tell it what to do. So we're going to say state is equal to high. If state is equal to high, then we need it to flash, right? You'll remember from our previous episode when we were working on timers, we need this to flash. So digital write, LED is high, and I'm just going to quick copy this real fast. We're going to Control C and Control V, but we're going to change that to the buzzer. And then we can say else, because now we're done with that. And we're going to come down here and repeat the process. Copy. And now we're going to say low. And then that's your switchback. So it'll read this back and forth. If state is equal to high, turn on, else turn off, right? So, all right, let's see where we are at. Let's make sure we're connected. Let's go ahead and upload and see if we can get it to read out. And we've got a couple of issues. And it would probably help if I didn't try to spell state and status on the same line. Oh yeah, make sure to close that out. It's probably going to freak out on me one more time on that. Oh, I got a lot of stuff wrong on this one. Ooh, go away. Put the digital right there. Holy cow, I am just being an atrocious speller right now. Did I still get those right? I apologize. I can't see the screen very well right now. There we go. Because I have it on pin 13, it's going to freak out when we upload this. But, see, it saw me. So it's going off now. I have a resistor in place of that wire for the buzzer, so it's not very loud. If we were to take this out and directly connect it to ground. I missed it. Right. It's very much louder, and I'm not going to torture you with that any longer. But as you can tell, I'm going to turn off the light so it's a little easier to see here. When the sensor is not reading anything, you'll notice that's off, and then when it's triggered, you'll notice the dome actually lights up. That's how you can tell it's actually picked up some motion. We'll come into, did I set up serial monitor? I set it up, but I don't think I assigned it, did I? I did not. So inside a loop, let's go ahead and set up the serial. And we're going to say increment, because we want to see what increment's doing here. So we'll upload that. Once this uploads, we'll switch back over to serial monitor, and you'll see that it's reading 0 at the moment because nothing's going on. And then, you know what? Now, should we sit here for a whole minute and do this? Probably not. But anyways, we'll hit that, and you'll see it starts going, and the buzzer would be going off right now too. And what's going to happen is this is going to count that 30,000, and once 30,000 has elapsed, it's going to add 1 to count, or increment. This is going to keep track of increment. It says once increment is more than or equal to 2, then to stop. That becomes false, right? It will no longer read after that because it will be a false statement, so it'll read low. So it will stop the blink, and in this case would be the buzzer. It would stop. And I probably should have put mils up there as a timer so that way we could see what this is doing as well. Because all we can see is what increment it can see, so we don't know right off the top of our heads how long this is going to blink. But, yeah. So, once it is activated, though, this second timer will go off, and that's what controls the blink. So, like I had mentioned earlier, this is going to be non-blocking. So, all this can be operated all at the same time. And we could even trigger the sensor again and reset this timer. And I probably should have used a very much shorter timer on this, so that way it was wouldn't have to wait so long. So let's go ahead and drop this down to, oh, I don't know, 10,000. So that way it's not going to take us forever to do this. And then we'll trip it, and it'll start going off. And here in a second, we should actually see it increment. There it goes. So you can see how it incremented to 1. So that means 10,000 milliseconds has elapsed. And it'll count to 2. See, and once it hit 2, it stopped. So it has elapsed the time and then shuts off. So the reason why we have it set up like this, and the reason why we have like this command right here, is this right here. So what happens if someone's doing this, triggering the sensor, right? And the sensor will then shut off. As you can see, it will shut off right there. And then the timer will start going. We can go over here and trip it again, and you can see that the count has now reset itself back to 0. So then when you move away, when the sensor turns off again, the timer will reset itself and then count all over again. So essentially, this has got like an unlimited ability to keep track of movement. So if something goes away and comes back into view, it will reset the counter every time while it's running, and then essentially will keep on running as long as it sees motion. So you won't have to wait for a timer to elapse, and then it'll start over and do it again, right? Okay, so we're done with that example. Now we'll do a little bit of a change up here. So we don't need... let's see here, high and low. We can keep everything in loop the same, but what we're going to do in here is we're actually going to get rid of all of this because we don't need it anymore. So we'll hit Control and slash to comment all those lines out, and we're going to change state. We're going to change state to val, because now we just want it to read just directly off this information and have it directly into a comparator. So what we'll do is we'll take this LED out, and we will put a standard LED in here to light up. And we can even we'll take this PIR sensor out, and we'll put in the radar, the Doppler. We'll put that in, and we'll show that example real quick and see if we can trigger it underneath the table. Let me look at the pinout real quick to make sure this is... I'm going to plug it into the breadboard correctly, because even though it does use the same pins, they're not in the same order. Okay, center is purple. We're going to switch those two around. Okay, so what we can do then is we're going to say that this is ground, and we have got blue as power. In my case, it might be different for yours. And then purple is going to be the signal. And then let's go ahead and upload this again. Okay, I'll move up. See, there we go. So now it's just staying on. It's not going to freak out and blink and buzzer. And so this is a lot more reminiscent of that, what was that, the yard light. So it's a lot more reminiscent of this now. It does exactly the same thing. So you know, see how it turned off. So every time you trip it, see, I'm moving it, so it's catching that motion. So it will stay on for that predetermined amount of time and count those loops again. And I'll put this in GitHub so you can see it and copy it if you want to, use it, modify it, whatever you want to do. But I will also add a chart in there that shows you how many milliseconds equals how many minutes. Just be aware, like I just said, for some odd reason the 60 millisecond timer is not working, so I had to switch this over to the 30,000. It's not that big of a deal. It's just if you want it to run for a minute, you'll have to double these over. So if you want it to run for 2 minutes, you're going to have to put 4 in here, so on and so forth. But you can get this to probably run for, I don't know, however you want, really. You can easily get this thing to run for 2, 3, 4, 5 minutes if you actually had this set up as a yard light. And I think the actual motion sensor yard lights can do pretty much the same thing. So, I mean, there you go. I mean, that's pretty much exactly how those yard lights work, is this. But, okay, so now that we're at the end of the video, let's go ahead and we'll grab this sensor and we'll point it straight down. We'll let the timer elapse real quick, so that way, you know, I can't just go, hey, look what I did. But anyways, we'll point this thing straight down into the table. We'll wait for the timer to turn off. And then, okay, so there we go. So now it's off. So let's see if I can get my hand right there and we can trip the sensor. Oh, yep, see, there it goes. So, like I had mentioned at the beginning of the film, you got to be kind of careful with your sensors because they can penetrate some surfaces. Depending on the walls you have or how thick the walls are, or the floor for that matter, you might be able to pick somebody up in the other room or outside the building. So, kind of cool, but also can be kind of annoying depending on what you're trying to do. But kind of a nifty little thing. If you stay tuned long enough to this channel, we are actually going to be using these. I have a very cool project that I'm going to be getting ready for here, hopefully sooner than later. We are going to add automated lights to our stairway. And these are the sensors that we're going to use to trip the sensors at the top and at the bottom of the stairs. So, I hope you all stay tuned, and hopefully I can get this done sooner than later, because I would love to go over the process and show you how it's going to set up and how it's going to work. So, that's the end of the video. Thank you for making it to the end. I know that was painful. I hope you learned something. If you liked it, hey, drop a comment. If you wanted to see something I didn't show, drop a comment. If there's something that you'd like to see, drop a comment. Let me know. If I need to improve on something, let me know. I'm new at this. I have no problem in trying to improve the process. I'm trying to do my best at improving the process, and I'd love your input. And again, give me a thumbs up, subscribe. I'd love that. It would help me out so much. If you got any questions about anything, if you're having problems with any of the code, hit me up. We'll walk through the process, and I'll see what I can do to help you out. And again, thank you.